Okay, this is the first time I'm trying this, so I hope it works out well. Um, Basically, I just made notes here. I'm just going to explain to you why it works the way it does. Okay, so first the way we gotta describe this is we start with the actual definition of a parabola right here. Parabolas are all sets of points that are the same distance from the focus, which is right here, and the directrix is right here. So any point I pick here, it has to be the same point, the same distance it has from here to here. Or if I get one from here, same distance from here, same distance to here. And the vertex is always halfway between the focus and directrix. So let's say if I made my parabola right here, and the vertex is right here, then the directrix would be like right here, and focus would be right here. But they would always be the same here, between here and here. It would always be the same. So what is a focus? It's always on the axis of symmetry, which you know is this line that goes down the middle. I put this in the origin, or like right in the middle. I made the parabola right in the middle here to make it simpler. But as I had with this example here, if its parabola is like right here, axis of symmetry is there, the focus will always be on this axis of symmetry right here, and it will always be on the inside of parabola. So we have the parabola like this. The focus is never going to be like right here or right here. It'll always be on this side, which is the inside of the parabola. Now, now the directrix is always perpendicular to the axis of symmetry. So that same axis of symmetry I just drew for the focus, the same line like that. Usually it's actually a dotted line like that. The directrix is always going to be this way. And as for where it is, it always depends on the focus and the vertex. It's always going to be, like I said, it's always going to be halfway between those two, but it's always going to be perpendicular to the axis of symmetry. Perfect. So now, in order to actually derive that equation you see, the one we started here, what was it again? It was y equals x squared over 4yp. It's a confusing equation. So, sorry, not yp. 4, it's over 4p. It's a confusing equation, but we can make sense of it. So we're going to do that right now. So firstly, we got to start with the Pythagorean theorem. And I know it's like old ancient geometry stuff now, but the reason why is that every single point difference, no matter where you are, is always going to be a 90-degree angle. So let's say I had another graph right here. I had a point here, a point here. The best way to get to here always uses a 90-degree angle, no matter what. You can put it anywhere on a point. Let's do another one right here. I don't know, like right there. That distance, still a 90-degree angle right here. So that's why it always uses, it's a right triangle. It always uses the Pythagorean theorem, which, if you remember, is a squared plus b squared equals c squared, which you can think of like the hypotenuse, this, is always equal to the horizontal leg plus the vertical leg squared, just because, I don't know why, but just because. Now, this picture looks a little confusing, but I promise we'll make it easier. So I'm basically comparing a point. So we're going to use any point on this parabola. Here I chose this one. I'll go back to the pointer. I chose this one right here. So this point is just xy. It's just the, oh, just like that, xy. And the distance we're choosing, well, we're going to start with the focus here, which is above here. So distance is going to be between these 2 points. Now, in order to have that distance, the hypotenuse is this one, right? Horizontal is this value, vertical is this value. So the reason why we say x minus 0 here, okay, wait, sorry, let me slow down. Um, the reason why this is a square, well, you can see why, because we want to get rid of these later on. We already got rid of it here, but that's the reason why we make it a square root. Now, the a value here is the horizontal one, and the reason why we make it x minus 0 here is because the focus in this equation is 0 at this point. And then P is just the y value that we're just going to call it because that is um, I'm sorry, that is the distance between the focus and directrix for this equation. We're not putting in actual numbers because I'm trying to explain how the equation came about. This P is the same equation, is the same P from this equation right here, showing you where it comes from. So this P it first starts right here at the focus. Now the B squared is the vertical distance. So we made that y minus p because it's the distance from this y minus this p. So literally just y minus p, x minus 0, because we're comparing the distance. Like you would compare the slope, change of x over change of y. It's the same thing. Uh, change of x would be like y1 minus y2, or sorry, y2 minus y1. This p is just y2. And then it equals the straight distance of any point to the f, which is this right here, also known as the hypotenuse. That's why that's c. C squared equals, let's say p squared, but we're getting rid of the square root anyway. So that p is equal to this. That's just the distance. That's just what we're calling the distance. So that's everything for the focus part. Now directrix is a little simpler. Any point on this parabola here, any point going down, it meets the directrix here. Just meets a straight line, and it has to be like the opposite value of the focus here because it has to be equal distance. Remember, it has to be equal distance between halfway between the focus and directrix is the vertex. So this p-value, the opposite of that is always going to be where the directrix lies. So in other words, if you're trying to get to the distance again, you would do this p-value to this value. Let's say you're comparing y's. Let's say this is 5, this would be 0, and this would be negative 5 if we want to make it equal. So if this is p, it's always negative p. Just like if it's 5, it's always negative 5. Okay, anyways. This looks a little more confusing, but the reason why we use the absolute value is because we're comparing it to a distance. It doesn't matter what value, if a distance is negative or not. We're just trying to get the point between these two things. If it could be either 5, it could be negative 5, depending on where you start. But we just care about how far it is, not which way it is, if that makes sense. So, yeah, an actual distance can never be negative, unless you're, no, they're just, in a distance, it's never negative. That's, so this equation is y plus p, because you're subtracting the negative p from the height of this. So like we're comparing the y values again. Y minus y2, sorry, y1, I'm sorry, y2 is this one, minus y1 is this one, negative p. Y minus p is just the same thing as y plus p. And then we have absolute value bars because we don't care about if it's negative or not. That gives you the equation for the directrix. And here's my other example, like I was showing. If the p-value is 3, p-value is 3, the focus is going to be 0, 3, the vertex is going to be 0, 0, and direction is just going to be negative 3 because it's straight down from the middle. Now we're going to revisit this again, this definition. A parabola is the points that keep an equal distance to f and d. In other words, the distance to f is always going to be the same as the distance to d. So, like in this problem, the distance to here is always the same distance to here, even though it doesn't look like it. So I know this looks a little daunting, but we just got these equations. So this f part I got from here, is the same thing as from here. And this distance to D thing is the same thing that I got from here. So let's just solve this equation. It's a little hard to show after I've already done it, but the first thing we're going to do is square both sides to get rid of this square root right here. And the reason we can square this part even though there's no square root is because it's an absolute value. So usually the reason you can't square something is because you're going to lose a value to like a negative, but because it's an absolute value, you're never going to lose a negative value because there's never one in the first place. So that's why you can square both sides. Once we do that, we get rid of the absolute, we can keep the absolute value bars, it doesn't really matter, but we get rid of them because we squared it. So that's like it's eliminating the possibility of a negative value ever here because we squared it out. So no more square root, no more absolute value. So we just have this and this. And now you don't like foiling, I know, but it's not like you're gonna have to do this for an actual test. I'm just showing you why it works. So I already foiled it for you here. It expands into y squared minus 2yp plus p squared. And then on this side, because it's a plus, it's y squared plus 2yp plus p squared. And every time you get this on two sides, you can always cancel like terms. So like if this is on this side and this side at the same time, we don't really need it. So we can get rid of that. Same thing with this p squared. It's also on this side, so we get rid of that. And then now we have, after we get rid of that, we just have this stuff remaining. X squared minus y, x squared minus 2yp is equal to 2yp this way. So, you know, whenever you have it like a system equation or something, you're always trying to isolate one variable. So here, let's say we just do x because it's simple. We add 2yp to both sides like this. That leaves us as x squared is equal to 4yp only. Now, if we're trying to get back to the original equation we have, all we have to do is just divide by 4p. And suddenly you have x squared over 4p is equal to y. Or otherwise, the same exact thing as what we started with up here. That's how you get to the actual equation. That's the reason why it works. Now I color coded it here. You can see which part comes from which. So this x squared comes from the focus. This 4p comes from the directrix. But when you're actually looking at it, it's just one equation that works, that you can plug in, that you can memorize. But the reason why it works is because of all this right here.